Hello and welcome. We are talking about division today. Unit 3, Lesson 5. We're in Integrated 3. So basically, we've looked at adding, subtracting, multiplying with numbers in elementary school, with polynomials in high school. And division is going to work in a very similar way. So how the lesson opens up is, let's think about factors, factoring, in fact, because that's the simplest form of division. So here's the area model. You know, this thing is not drawn right. This is X right here. This is not supposed to be this long. It's only supposed to go here or so, because this is X. This is not supposed to be here. Okay, so you have an X square. You got 7 X's. There's 5 of them over here. There's 2 of them here. And you have 10. Now, according to the area model, if I take an X distance plus 5 more, and an X plus 2, right? There's an X and a 2. These two, that would be length and width, multiplied together, give you the area of the rectangle, and that's X squared plus 7X plus 10. That means X plus 5 divides into X squared plus 7X plus 10, and so does X plus 2 divide into X squared plus 7X plus 10. So just as a quick little review here of what we've done in Integrated 2, factoring these kind of things, you probably were told that you need to think about two numbers that will, and maybe there was an X that was drawn, two numbers that will multiply to 12 that will add to 7. And you just try to guess what those two numbers are going to be. That's a pretty easy one. That's 3 and 4. So this would be X plus 3, X plus 4. Let's do just one more. Okay, so this one would be, can you think of two numbers that multiply to negative 15 that add to 2? And without too much thinking about it, hopefully you'll come up with 5 and a negative 3. So it's X plus 5 and X minus 3. Either of these two will divide evenly into the original polynomial. So let's skip these. That's probably enough to get your memory going the right way. Back to Integrated 2. Now let's do it a different way. So you might remember from elementary school, long division. So we're going to use an analogy here. We're going to say, look how we did it in elementary school, and look how you do it now with polynomials. And there's lots of words here on the side for you to read if you need to. But basically, if you just follow along, it's a very straightforward process. Do this, do this, do this. You will get the answer. So back in the days of elementary school, we would say, does 12 go into 1? No. Does 12 go into 14? Yes. It goes one time. 1 times 12 is 12. And then subtract. Okay, now let's do the same thing over here in polynomials. You'd say, x times what is x cubed? Well, that would be x squared. And then we'd multiply that x squared by both the x and the 2. So then we get x cubed plus 2x squared. If you don't get the exact same thing underneath x cubed, then you did it wrong. You need to get x cubed. Oops, a little too far. Now, when we subtract both of these. See, back in elementary school, when we subtracted 12, we actually subtracted 10 and 2. Well, we do the same thing here. The x cubes cancel out. We get 4 minus 2x squared. That's 2x squared. Well, back in elementary school, what you then did is you brought down the next number. So we're going to bring down 5. We're going to bring down the 5, and we're going to ask ourselves the same question. 12 times what is 25? And that would be 2. 2 times 12 is 24. We have a 1. X times what is 2x squared? That would be 2x. 2x times x should be 2x squared. 2 times 2, 4, so 4x. And I should have brought down the 5x. We subtract this part we brought down. That gives us x. There's only one more thing to pull down. The 2 in elementary school, 12 goes into 12 one time. 1 times 12 is 12. No remainder. In polynomials, bring down the plus 2. X plus 2 times 1 is x plus 2. Subtract them and no remainder. So there's a multiplication fact inside of every division. In this problem that we have to the left, that means 12 times 121 equals 1,452. Well, in polynomials, that means x plus 2 times x squared plus 2x plus 1 is equal to x cubed plus 4x squared plus 5x plus 2. In words, the divisor times the quotient will equal the dividend. Now, that's all, of course, with no remainder, or the remainder turning out to be 0. Well, what if it doesn't equal to 0? Okay, so picking up again in the lesson, we have no remainder. So right here. So that means that the number is a factor. 12 is a factor of 1452. And so x plus 2 in the same way is a factor of x cubed plus 4x squared plus 5x plus 2. Polynomial division doesn't always match up perfectly to whole numbers in division, but the process matches up. The process is the same. So we're going to walk you through another one here. We're going to take x minus 1 and divide it into x cubed minus 3x squared minus 13x plus 15. So then I say x goes into x cubed how many times? In other words, x times what is x cubed? And that is x squared. Then I multiply x squared times x. I get x cubed. And x squared times negative 1. I get negative x squared. So in other words, you distribute this to both of those. Okay, now I subtract. Negative 3x squared minus a negative x squared. Double negative, so it's got to be plus x squared. This is negative 2x squared. Then I think x times what is negative 2x squared? That would be negative 2x. Multiply it here. And also negative 2x times negative 1 is positive 2x. I should have brought down the negative 13x. Subtract them. Okay, so the first term should always subtract away to be 0. If it doesn't, you did it wrong. And then we have negative 13x minus 2x is negative 15x. Let's bring down the 15. X times what is negative 15x? Negative 15 times x. And plus 15. And this one also has a remainder of 0. So that means x minus 1 is a factor of the original polynomial. Okay, here's another one to try. This one now is a little different. It's got a 2. So we got 2. Let's see. Let's draw this in black. 2x plus 3 goes into 2x cubed plus 7x squared plus 2x plus 9. All right, so 2x times what? So I'm looking at specifically here and here. 2x times what is 2x squared? Well, that's just another x squared. Then I multiply. Subtract. So 2x cubed cancels out. 7x squared minus 3x squared is 4x squared. Bring down the 2x. 2x times what is 4x squared? That would be 2x. Giving you 4x squared plus 6x. Subtract. 2x minus 6x is negative 4x. Bring down the 9. 2x goes into negative 4x. How many times? Goes in there negative 2. And there will be, again, no remainder. So here's where the lesson says, well, what if there's a remainder? It says when dividing numbers, there are several ways to deal with the remainder. Sometimes we just write it as like this. We use an R. 8 with a remainder of 1. But sometimes we write it as a fraction, 8 and 1/3. So we take the remainder and we put it over the original divisor. Well, that's the one that we use with polynomials. So let's see. Did I not do that right? I don't think I did that right. I assume there was no remainder. I didn't actually check it out. Let's see. So 2x, oh yeah, I totally messed the last part. 2x minus 6x would have been, okay, hold on. Negative 4x minus 6. Oh, there we go. And the remainder is 9 plus 6. So the remainder is 15. Ah, okay. Sorry about that. Now you look at this, what they wrote right here. You can use it to write two multiplication statements. So this is divisor times quotient plus 15 equals, right, whatever, the original dividend. But also you can write 15 over the original divisor. 15 over 2x plus 3. And it would work because if you distributed this term over here, you would just get 15 out of that. And that was the missing part. So now it says divide each of the following polynomials, write two multiplication statements that go with your answers if there is a remainder. Write only one multiplication statement if the divisor is a factor. Use graphing technology to check your work and make the necessary corrections. So we're not going to do that in this video, but you could use Desmos or something like that to graph it and see if your statements are equal to each other. Number 5, part A. So we're dividing x plus 3 into x cubed plus 6x squared plus 13x plus 12. We start by dividing x to the third by x. In other words, what do you multiply x by to get x to the third? And that's x squared. And then multiply x to the second times x to the third, x to the second times 3 plus 3x to the second. Then we subtract. X to the third always will cancel with x to the third. The first term will always cancel and turn to a 0. Then we have 6x squared minus 3x squared is 3x squared. So that three-step process will repeat, where you basically divide, multiply, and subtract. This was the division, x to the third over x. That gave us x squared. Then, with x squared, we distributed here to the divisor, and then we just subtracted. So now, as we do that again, we bring down the 13x. It's like a new problem. You do the same thing. You divide 3x squared divided by x is 3x. Multiply 3x times x, 3x squared, and 9x. Subtract. 13 minus 9 is 4x. Bring down the 12. Last time we're going to go through those three steps. So 4x divided by x is 4. 4x plus 12. 4 times 3 is giving us 12. 0 remainder. So that means the multiplication statement is going to be x plus 3 times x squared plus 3x plus 4 is equal to the quotient, the dividend, x to the third plus 6x squared plus 13x plus 12. So that means x plus 3 was a factor. So let's see. X minus 2 into x cubed, 4x squared, 2x plus 5. Let's get a different color going here. How about blue? So x squared gives me x cubed minus 2x squared. 4 minus negative 2 would be 6x squared. Then add 6. 6x squared. Bring down 2x. And let's see. Did I miss something? 6x. And that would be negative 12. Subtract them. 2 minus negative 12 would be 14x plus 5. And this would have to be 14. So 14x. 14 times negative 2, negative 28. And that would be a remainder of negative 23. Okay, so if I wrote this the long way, it would be x minus 2 times the quotient x squared plus 6x plus 14 plus negative 23 over x minus 2. Well, that actually goes over the whole thing like that. And that is equal to the original dividend, x cubed plus 4x squared plus 2x plus 5. You notice on one of the styles, the remainder is inside the parentheses, and the other one, the remainder is not inside the parentheses. Okay, so now we got a few more to try. D would probably be the most complicated one. So we're not going to put that in this video. We may or may not have time to try that in class, but we need to get to this fact. There's one more interesting thing to notice with division of polynomials. Look back at problem 5b. Okay, this is the one with a remainder of 27. It says, let's use a function, find f of 2, and compare it to the remainder you found when you divided f of x by x minus 2. So f of 2 is going to be 2 cubed minus 4 times 2 squared plus 2 times 2 plus 5. And that's 8 minus, let's see, 2 squared is 4, so 16 plus 4 plus 5. Let's see, that's negative 8 plus 9 is 1. That is not quite right. Something is wrong. Did I do 5b wrong? I think I might have done 5b wrong. I wish I didn't make these mistakes. Okay, let's see. 13. Okay, tell you what, don't pause the video, I'll just cut this out. All right, I just figured out what I did wrong. I wrote it down wrong. This is a minus sign right here. All right, so let me clean this all up. We'll try that again. This is all wrong. All right, let's see, let's get rid of this. We'll just get rid of this and do it over again. All right, x goes into x cubed, x squared times, that's x cubed minus 2x squared. Subtract the 2. It's negative 4 plus 2x squared is negative 2x squared. Bring down the 2x. X times negative 2 is negative 2x squared. 2x is negative 2x squared. That's negative 2x squared plus 4x. Subtract them. 2x minus 4x is negative 2x. Bring down the 5. X times negative 2. So negative 2x plus 4. Subtract them. And the remainder is 1. So another way to write this is if you do x minus 2 times the quotient x squared minus 2x minus 2 plus, for the remainder, 1 over the divisor, x minus 2. And that's supposed to equal the original dividend. There. Okay, now we don't have time to do these next two. However, there's an interesting thing to notice is that when we plug in the number 2 into that polynomial as if it was a function, we get the same answer as the remainder. So then it says, well, go ahead and try it with this one. And we're going to divide x plus 3, but we're going to look at f of negative 3. So we're going to look at the opposite. So if you divide x plus 3 into x cubed plus 5x squared minus 3x plus 4, just changing colors. Okay, x squared, that will give me x cubed plus 3x squared. Now I subtract 2x squared, bring down negative 3x. X times, or x, 2 times x will give me 2x squared plus 6x. Subtract them. That's negative 3 minus 6x will be negative 9x plus 4. Then do a minus 9, and that'll be negative 9x minus 27. And that will be, if I subtract them, 4 plus 27, that should be 31. Okay, now if I take f of negative 3, that would be negative 3 cubed plus 5 times negative 3 minus 3 times negative 3 plus 4. Negative 3 cubed is negative 27 plus negative 15 plus 9 plus 4. Oh, something's gone wrong here. This is squared. So let me replace that with, let's see, 5 times 9, that would be 45. Okay, so my total positives here are 45 and 13. So I have 58. And let's take away 27. And sure enough, you get 31. So based on those two examples, the remainder is the function value as long as we use the opposite of what we're adding to x. So when you have x minus n go into the function, the remainder is equal to the function value at n. And that is very useful. That is called the remainder theorem. The remainder theorem says that the remainder is the function value at f of n. So notice there's an element of being backwards there. X minus n is the factor, but you have to put in f of n to be able to get the remainder. Okay, look at the example that they've given for you here, laying it out as something you can turn back to later. Okay, well, that's about it. We'll see you next time.